Good day everyone. I will be presenting the solutions and logical behind Midterm Laboratory 1 and 2, which cover Python functions, loops, and conditional statements. These activities focus on creating reusable functions, making decisions using conditions, and processing repeated input using loops. There are five different problems, each designed to apply core programming concepts in different scenarios. The first problem was a function check even and odd that will determine whether a number is even or odd. Inside the main program, the user enters five numbers one at a time inside a loop. For each input, the program calls the function and checks if none is divided by 2, the main loop is 0, or is equal to 0. The number is even, otherwise the number is odd. Two counters are also used to keep track of how many inputs fall into each category. This demonstrates how a function can be used to avoid repeating code, how modulo identifies whether a number is divisible by 2, how a loop collects multiple user inputs, and how counters store running totals. At the end, it prints how many numbers were even and how many were odd, showing correct data classification. And for the problem 2, factorial calculator. The second problem is about computing the factorial of a number using a function named find factorial. A factorial means multiplying all whole numbers starting from 1 up to the given number. Inside the function, a variable is initialized to 1 and a for loop multiplies all numbers from 1 up to n, continuously updating the total. This problem shows how functions can return values using the return keyword, how loops can perform progressive calculations, how mathematical logic can be implemented using iterative processing. And for the problem 3, which is simple discount system, it defines a function called getDiscountAmount, which determines the final price based on a discount rule. The rules are if the purchase amount is 1,000 pesos or above, apply 10% discount. Otherwise, no discount. The conditional logic inside the function checks whether the value meets the requirement. If yes, the function returns amount minus parenthesis amount multiplied by 0.10 parenthesis. If not, it returns the original amount. This problem demonstrates practical usage of decision-making, if-else, percentage calculation, function return values, and real-world application like shopping and payment systems. And for the fourth problem, which is temperature category, in this activity, a function named checkTemperature with the open and close parentheses, including temp, identifies whether a temperature value falls under. The range is below 20, the category will be cold, and 20 to 30 will be warm, above 30 will be hot. The program then asks the user to enter 5 temperature readings using a loop and calls the function for each one. The output prints the reading together with its category. This problem shows how conditional structures can be used not just for math but also classification based on range, which can be useful in weather analysis, thermostat and cooling systems, and sensors-based monitoring. It also reinforces converting repeated tasks into functions for better code quality. And for the last problem, which is number guessing game, where the computer generates a random number from 1 to 10, and the user must guess it with the limit of 3 attempts. And the function named checkGuess compares values and returns. If too low, if guess is less than secret. Too high if guess is greater than secret. Correct if guess is equal to secret. A loop handles multiple attempts and stops when the user guesses correctly or when attempts run out. This program demonstrates the use of random module to generate unpredictable values, return statements for feedback messages, loop control which can either continue or stop, and real example of input validation and interactive programs. And for overall analysis, all 5 problems highlighting how functions, loops, and conditionals work together to form flexible and reusable Python programs. Functions help divide a program into smaller, organized parts. Loops allow multiple inputs and repeated processing without rewriting code. Conditionals enable decision making based on different values and conditions. These features are fundamental in building more advanced programs such as automated calculations, games and simulations, data processing tools, scientific, business, and real-world applications. And that's all.